Hello everyone, in this video I am going to discuss the fate of bilirubin. Now first of all, we need to be very much clear that bilirubin is formed by the RBC destruction. Now RBC destruction leads to the formation of the bilirubin. Now bilirubin in the plasma, it is getting bounded to the albumin. After the destruction, this get bounded to the albumin. So in this fate of the bilirubin, first of all, there is the thing we need to notice. First step is the uptake, that is bilirubin formed by the destruction of the RBC is free here and gets bounded to the albumin. Now this free bilirubin, it is lipid soluble and hence cannot be excreted in urine So then on reaching the liver, now this first of all the first step is completed here, that is this free unconjugated bilirubin, it is getting bounded to the plasma. The second step is conjugation. Now uptake by the liver has occurred. Now conjugation here we need to understand that the conjugation is with this albumin is first of all detached here the albumin is removed and only the unconjugated bilirubin is entering the liver. This unconjugated bilirubin is getting conjugated with UDPGA. So this process is the hepatic conjugation. What is hepatic conjugation? That is unconjugated bilirubin entering the hepatic cells is conjugated with the uridine bisphosphoglucuronic acid and it is catalyzed by the enzyme glucuronil transferase. Then this unconjugated bilirubin, when conjugated with uridine bisphosphoglucuronic acid, leads to the formation of mono and diglucuronides. Then this hepatic conjugation has occurred. So first step uptake, second step conjugation. Now the third step is the excretion, which is the hepatic cells which has formed this conjugated bilirubin. This is the conjugated bilirubin which is formed by the hepatic cells is now excreted, and this excretion of the conjugated bilirubin into the bile canaliculi is an active process. So therefore this is a rate limiting step. In the fate of the bilirubin. Then the fourth step is the degradation. So now when the conjugated bilirubin is excreted into the bile canaliculi, that is an active process. The next step is the degradation. Now in this the glucuronil acid which was conjugated with the free bilirubin, it is removed. Glucuronil acid is removed and bilirubin forms stercobilinogen. Okay, so this is how the further degradation, that is the first major step is the glucuronil acid is splitted from the bilirubin and bilirubin undergoes reduction to form stercobilinogen. Now the fifth step is the re-excretion. In this, what happens is the 20% of this stercobilinogen. Now this stercobilinogen which was formed in the degradation process by the colonic bacteria. The degradation is with the help of the colonic bacteria in the colon. So In this 20% of the stercobilinogen, what I'm saying is 20% of stercobilinogen is reabsorbed into the portal circulation. So now in the portal circulation, then again from here, when this reabsorption is occurring, then again it will be moving to the, again from the reabsorption, from this part, after this process is occurring, then this is taken up by the liver. So 20% is taken to the liver, then again it will enter the enterohepatic circulation to drain into the colon, and remaining it is getting filtered, and the remaining getting filtered and going to the kidney, so forming the urine urobilinogen or the urine bilirubin. So once again I'm repeating the re-excretion, the fifth step, that is 20% of the stercobilinogen, it is absorbed in the portal circulation, which enters the liver again. Now this, either what fate will occur, either this 20% reabsorbed stercobilinogen will be reabsorbed in the enterohepatic circulation, or will be excreted by the kidney in the form of urine urobilinogen. Now this was the fate for the 20% of the stercobilinogen. The 80% of the stercobilinogen that was formed by the colonic bacteria, this 80% will be excreted stercobilin in the form of stercobilin. Further stercobilin will be excreted, and the amount of this removal of the fecal stercobilinogen is 20 to 25 milligram per day. So this is the whole cycle. I am repeating it once again. The first step is the uptake, the second step is the conjugation, the third step is the excretion, the fourth step is the degradation, and the fifth step is the regradation. अपटेक में क्या हुआ, जब हमारी आरबीसी की डिस्ट्रक्शन हुई तो फ्री एल्ब्यूमिन, जो फ्री बिलिरुबिन है वो एल्ब्यूमिन के साथ बाउंड कर गया, एंड दिस वाज एक्चुअली lipid soluble and it cannot be excreted in the urine. This was first step, that is uptake. Then it is taken by the liver cells, that is the hepatic cell uptake. Then is the conjugation, that is hepatic conjugation, जिसमें क्या होता है, this unconjugated bilirubin, it is getting conjugated with uridine disphosphoglucuronic acid in the presence of glucuronyl transferase to form mono and the diglucuronides. Then the third step is the excretion. This formed conjugated bilirubin is excreted in the bile canaliculi system, that is an active process, so there is a rate limiting step. Then fourth is the degradation. Degradation occurs by the bacterial conjugation, which is bacterial deconjugation occurs, that is the bacteria in the colon will degrade the conjugated bilirubin, and bilirubin will be converted into stercobilinogen, and degradation से पहले क्या होता है, glucuronyl acid is removed. Now the fifth step, that is the re-excretion. The stercobilinogen that was formed here, 20% is absorbed into the portal circulation and enter the liver once again, and further in enterohepatic circulations again it will be recirculating, or it will be going to the kidneys for the removal in the form of urine urobilinogen. And now the 80% stercobilinogen is excreted as fecal stercobilinogen with the rate at the is 20 to 250 milligram per day.